Hello there, DPC here. Can't tell you how many times I've re-recorded this. Take 13 or whatever. So I want to briefly explain this image, and the transformation of this image, and the plugin that I use to do that. So quickly through the plugin. So this is what it looks like. Basically, in this field, I can type in whatever function I want. So like log of z, and it's going to transform the image by that function. That's just how it works, right? The math portion, not so important. What is important is the way that the transformation occurs, at least for our purposes. So, a couple things to observe. One, the plugin treats this as the origin, right? The center of the image, which is demarked by these lines, right here. That is the center of the image. Actually, it should be there. Something. I don't know why the circle is offset. But yeah. So there's that. Then another thing to observe is because this is the origin, this is considered the coordinate 1, 0, or 1 plus 0i, or just 1. 1. So that's 1, and if that's 1 and that's the origin, then that must be I, and that must be negative I, and that must be negative 1. Again, the details aren't so important. I just wanted to draw the attention to the origin and to 1. Finally, this guy is looking straight at the center of the image. And along the way, he passes through this pie creature. And, if there were a pie creature here, you can kind of see blue pixels. If there was a guy here, he'd be seen, right? And we can deduce through the intent of the artist that there's supposed to be a theoretically infinite number of copies as you get closer and closer to the center. Oh yeah, that's right. And I guess one other, well, this will be important later, but this is just a grid. So as we zoom in, you will notice that these circles, well, I'll just say, these circles are a zoom factor of 2. So this outer circle is just a zoom of 1. Then as we zoom in, this is a scale of 2, and then a scale of 4, and then 18, and then 16. So what this tells us is that this small window is hold on, I didn't press the right key, is 16 times smaller than the original image. Cool transition, I know, really cool. Anyway, here's the logarithm of the image. So these lines that you see, these vertical lines, these correspond to those circles that we saw earlier. So if we look at this pie creature, right, and we go counterclockwise, we see the best way of doing that, I guess, where this guy's eye is, right? We go counterclockwise, we intersect the vase, and then we make it through this little part of the window thing, and then we clip this part of the frame, and then we look at the back of that guy's head. Similarly, if we go along this line to this guy, we're going to notice that we go through the vase, we go kind of into this weird part of the window, we clip that corner of the frame, and we look at the back of this guy's head. So what this does is it turns circles into horizontal lines. Again, the fact that this is the logarithm of the image isn't really what we're focusing on. We're focusing on the effect, the transformation. So circles now look like, circles centered on the origin, now look like vertical lines. What about the horizontal axis? Because I noticed this guy over here. So if we draw a line from where this guy's looking, right, to the center of the image, we create this line. That's important to know. Because when we look at where this guy's looking, we draw a straight line to where the guy would have been looking, right? This guy would have been looking through this guy's eye, through that guy's eye, all the way to the center of the image. Strangely, this ends up going to the left. And if there were more copies over here, I could draw the line going all the way over here. What's going on exactly? Well, one other thing to observe is this right here. Just to solidify our understanding a little bit. So what we're looking at is just this right here. You see? We're looking at the wall, the far right of the wall. The reason why this is positioned like this is we can take a look at the logarithm function. Not going to be on the test, so don't worry. But just know that when you input 1 into the function, you get 0. Let's go back here. This is 1, right? As I said before, this is the origin, this is 1. So this is 1. And where does this wall end up? It ends up right here. It also ends up smaller, but don't worry about that fact. The fact is, we transformed 1 to the origin. What about the middle of the image? Well, the middle of the image is at 0, right? 0, 0. So as we continue approaching 0 on the x-axis, the input of the function, we notice the y, the output of the function, gets more and more negative. In fact, as it approaches 0, we get an undefined value because we're getting to negative infinity is what is happening. So as we go left, we're getting closer and closer to the origin, but we never actually reach it. We are actually we're going to have to go infinitely far to the left to end up at the origin. Because of pixel precision, we're going to end up seeing the color of the pixel way earlier. But the fact of the matter is, going left is zooming in to the image, closer and closer to the origin. That's why we see this guy, because this guy corresponds to this guy, right? So if we look here, this big guy corresponds to this big guy, and this little guy corresponds to this little guy. So who's this? Well, through the magic of complex numbers, things just kind of repeat. So again, let's look at the circle. Let's go counterclockwise. We see the vase and blah, 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 and we see the dude again. That's just what happens vertically. It's just what happens. Why? I don't know. Just does. Anyway, moving on from that, we can transform this image to another image. But we need to do something in between. You see, this guy's pixelated. And, like, bad looking. So, like, we don't want that. And also, half of the image is completely wasted. Like, there's no utility to this. We have half an image, and a third of it looks just pixelated. So what I've done is I've done this, right? I've made the image a little smaller or zoomed out, and I've copied this portion over here, and over here, and over here, here, and here, right? There's just a lot of copies of the image. What this lets us do is if we, I don't know, rotate it for some reason, we have plenty of information to work with. So the observation that this vertical line is a circle is really interesting because what this tells us is that as we go around the circle, we end up back where we started. But what if, instead of starting and ending at a copy, like a direct copy of the dude, what if we went from here to this guy? Remember, this guy is closer to the inside of the image. So what would effectively be happening is we are looking, if we trace the circle, right? We're going to be looking at the left side of this painting. We're going to pass by the sun, pass by this tree, through this house, through the bottom of this window, and into this guy's face. But to do that, to get this to be vertical, what we'd have to do is rotate the image and then scale it a little bit. And then eventually we have to find the opposite of this transformation, the logarithm, which is the exponent. So basically, the procedure is you take the log of the function, and then we do some stuff, doesn't really matter, and then we undo the log. So we do e to the z, right? Again, math isn't what's important, the transformation is, and we get this. So remember, as we go around the circle, we pass through the left side of the frame, by the sun, by the tree, into the house, underside of the window, back into this guy's face. I know my circles are terrible, my mom has told me many times. Anyway, what we've effectively done is we are looking into the image and producing this cycle, right? But then who's this guy? Like, who invited this guy to the party? Well, remember, when you have a vertical line, right? Pretend this is a vertical line. We are looking around in a circle. And when we have a horizontal line, which this is 90 degrees, or 90 degrees, when we get closer and closer to the origin, we see this guy, and this guy, and allegedly this guy. The point is that I drew this on the wrong dude. It should actually be here. But don't worry about it. Yeah, so we're going to see 1, 2, 3 copies of this guy if we zoom in far enough. And lo and behold, this guy's looking at... Oh, I didn't know you could do that. I don't know how GIMP works. Anyway, as we look closer and closer to the center of the image, we see 1, 2, and then this tiny little pixel. 3. We see 3 instances of the image. If we could zoom in... Shut up. If we could zoom in more, we would see more instances of the image if I chose this guy to be the center. Because I chose this guy to be the center, we would get transparent pixels. We would see nothing. There'd be nothing there because there's no information to go off of, right? But the fact of the matter is, in a perfect world, you could just keep on zooming. Zoom in and 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 zoom